So let's look at apportionment related to our government. The United States Congress is composed of two houses, the Senate and the House of Representatives. The Senate is made up of 100 senators, 2 senators for every state. The House of Representatives, though, is different. It's made up of 435 voting members. The number of representatives for each state varies depending on the population of that state. So what that means is that a state with a larger population gets more voting members in the U.S. House of Representatives than a state with a smaller population. These 435 seats in the U.S. House of Representatives are reapportioned, so redistributed, every 10 years after a census. Because what a census does is it looks at the population within the United States. And so you'll get a count of how many people are in each state, and you can reapportion, based on that population, the seats in Congress. So this happens every 10 years after a census. Now, each state in the House should ideally represent the same number of people. Okay? That's the ideal, that each seat represents about the same number of people. So if you think about doing that, that would be the total population of the United States divided by the number of seats. So that would be 435. And we would work out an ideal number of people. We call this the standard divisor. In 2020, the U.S. population was approximately 331.1 million people, and there were 435 seats in the House of Representatives. The standard divisor for the seats in the House of Representatives, therefore, was calculated as the total population divided by the number of seats. So that would be 331.1 million, and I'll just put out the zeros there so you can see them out if I were putting this in the calculator, and then dividing that by 435. So if we approximate that, because we do get a decimal number, but that ends up being 761,149. I'm just going to round the whole person here because it's so big anyway. So every district would ideally have 761,149 people in it. This is the ideal number of people per district. Now, in 2020, the population of Oregon was approximately 4.2 million. So if we use this ideal number to work out how many seats in Congress, or in the, I should say, in the U.S. House of Representatives that Oregon should get, we would take Oregon's population and divide by this standard divisor. So we take that 4.2 million, and I'll just convert that again to millions with all the zeros. And we're going to divide that by 761,149. When we do that, we get a decimal result as well, 5.52. I'll just round off at the second decimal place. But the main thing is, notice, this is telling us that we should have 5.52 seats in Congress. We can't have a portion of a seat, but this is giving us what would be the ideal if we could have a portion. We call that Oregon's standard quota. So the standard quota is the actual ideal. If we could have a decimal, it's 5.52. Now, we can't have a decimal. We can't have a portion of a seat in Congress. So Oregon is either going to get 5 seats or they're going to get 6. And that's what we have to figure out. Which is it? Is it going to be 5 or 6? And what Congress has to do is figure out how do they want to make that decision. And so we have different apportionment rules that have been applied over the different years. Now, how do we decide on what to do with those fractional or decimal seat values? Well, the U.S. Constitution requires that the seats in the U.S. House of Representatives be apportioned among the states based on population, but it doesn't say how. So Congress gets to decide and vote on what method is used. And initially, when the Congress was being formed, you had two political rivals, Thomas Jefferson and Alexander Hamilton, who each proposed a method for dealing with the decimal. In terms of voting, it went back and forth, but in the long run, Jefferson's method was used and determined to be used by Congress. And it was used from 1772 to 1832. But then things changed, and Hamilton's method became the favored method from 1851 to 1900. Now, as I mentioned, many methods were proposed, including while Jefferson's method was being used, a method called Webster's method, named for a Congressman, Webster, was proposed, and it was used once in 1841 and then abandoned for Hamilton's method and then used again in the early 1900s repeatedly. But then in 1941, a new method was proposed by a leader in the Census Bureau. The Hill-Huntington method was proposed, and it's the one that's been used from 1941 to present. So these are the four methods that have been used to apportion seats in Congress. Now, all four of these methods start the same way. They all start by finding a standard divisor based on the population. Now, that standard divisor is representing the ideal number of people that are represented by each seat in Congress. Now, you use that standard divisor to then divide the population of each state to get a standard quota. And the standard quota is a representation of the ideal number of seats that each state should have in Congress. That standard quota, though, is a decimal number. And that decimal number, we need to figure out how to take care of the decimal. So because the standard quota is a decimal, what happens is that each of these methods, these four methods that have been used so far in the history of our country, is that they all have a slightly different way that they handle the decimal. And they make the decision of who gets the lower number of seats, who gets the higher number of seats in terms of that decimal. So that's what we're going to investigate, is we're going to look at each of the four methods and look at the mathematics behind how you choose whether a state gets to round up or gets to round down in terms of the value of their standard quotas.